A ring, where a ring had no business existing. That is what a team of astronomers found. They had pointed their telescopes at a single star, watching it disappear behind an object nearly 4 billion miles away. They expected to confirm a shape. They found something else entirely. By the end of this video, you will understand why one small world keeps forcing scientists to redraw what a planet is allowed to be. Most people can name one dwarf planet, Pluto. Maybe two if they remember Eris, the object that got Pluto demoted. Almost nobody has heard of Haumea. The International Astronomical Union named it after a Hawaiian goddess of childbirth and fertility. Its 2 moons carry the names of her daughters. Nobody planned that connection to be fitting. It just turned out that way. Haumea is the 3rd largest dwarf planet the Union officially recognizes. It orbits far beyond Neptune, out in the same cold, distant region as Pluto, roughly 4 billion miles from the Sun. On paper, it should not stand out much. Ice, rock, cold, far away. The usual profile for that part of the solar system. Except Haumea spins. Not the way planets normally spin. It completes a full rotation in under 4 hours. Earth needs 24. That single fact turns out to explain almost everything strange about this world. And it does not stop there. Spin something fast enough, and it stops being round. Pizza dough flattens. A wet tennis ball on a string bulges at the middle. Haumea does the same thing at planetary scale. Astronomer David Rabinowitz and his team watched Haumea's brightness rise and fall twice during every rotation, once for each long end of its shape. That pattern is the signature of an object shaped less like a ball and more like a stretched egg. Their 2006 paper put the full rotation period at 3.9 hours. Nothing else that size spins nearly this fast. Where did that spin come from? Nothing this size should be born spinning that fast on its own. The result is a world roughly twice as long as it is wide. Stand at one end and the surface curves away almost like a football. Stand at the pole instead, and you are looking down the short axis of a body that physics is actively fighting to hold together. Why it holds together at all is a question for later. First, another discovery got in the way. For over a decade, that stretched shape was mostly a calculation, not a direct observation. Then, on January 21, 2017, Haumea passed directly in front of a distant star. Astronomer José Luis Ortiz coordinated 12 telescopes across 10 locations in Europe to watch it happen. For a few seconds, the star's light blinked out as Haumea passed in front of it. Every flicker in that data was a clue to Haumea's true size and shape. The results, published in the journal Nature in October 2017, changed 2 things at once. Haumea turned out to be bigger than anyone had measured before, which meant its density was lower than expected. Not rock hard, like earlier estimates suggested, closer to the density of Pluto. And then, nobody had been looking for this. Hidden in the data was a ring around a body smaller than Pluto, out past Neptune, where nothing was supposed to have rings at all. For decades, rings were something only giant planets were supposed to have. Saturn, Uranus, bodies massive enough to hold one in place. One small world, Chariklo, had already broken that rule back in 2014. Haumea's ring was the first ever found around a Kuiper Belt object, and it would not be the last small world to surprise us. A ring is strange enough, but Haumea already had 2 moons, Hi'iaka and Namaka, discovered in 2005, orbit close to their parent world. They are not alone either. Scattered across Haumea's orbit, astronomers have found an entire family of smaller icy bodies. Every one of them carries the same unusual signature of pure water ice. That shared signature is the clue. In 2010, astronomer Zoe Leinhardt and her team traced the family, the spin, and the moons back to what looked like one event. Not a violent, planet-shattering impact. Something stranger. A slow, grazing collision where two icy worlds touched, merged, and spun apart again under their own momentum. Picture two worlds brushing past each other at just the wrong angle, not colliding head-on, grazing. The impact did not destroy Haumea. All that momentum had to go somewhere. It spun the merged body up until material tore loose, two moons and a trail of smaller siblings. What was left behind was the fastest spinning large body we know of in the solar system. Not everything about Haumea adds up yet. Whether physics is actually winning that fight to hold it together is still an open question. Scientists do not know for certain whether Haumea has settled into a stable, smooth balance the way most spinning bodies eventually do. Researchers call this hydrostatic equilibrium. A study published this year in the journal Astronomy and Astrophysics, led by Julie Castillo-Roges, modeled something unsettling. If Haumea truly is in that balance, its surface might not be smooth at all. It could be pinched at both ends, a shape that only appears right at the edge of stability. The models suggest that deviation could stretch across nearly 70 miles of Haumea's surface. That is not a rounding error. That is a completely different kind of world. If it is confirmed, it would also support a different idea: that the moons and the family were not carved off by a collision, but shed directly from a body spinning at its limit. That is still a model, not a confirmed measurement. Here is what stays with me about Haumea. We used to think planets were simple, round, because gravity always wins, always smooths things out given enough time. Haumea is what happens when something spins too fast for gravity to finish that job. A world caught mid-transformation, not settled, not simple. A body still negotiating with its own physics, roughly 4 billion miles from a sun most humans will never think about twice. On May 4th, 2026, Ortiz and his team pointed their telescopes at Haumea again, watching for another star to blink out behind it. That data is still being analyzed. Somewhere in it may be the answer to whether this small, fast, strange world is stable, or whether it is still, quietly, coming apart. Somewhere out past Neptune, a world spinning too fast to be still is waiting to find out what it actually is. Thanks for watching.